Alright, let's take a look at Logarithmic Functions 2.3. Now, for some reason my pen tool I upgraded and I have to go really slow to get the lines. So it's maybe kind of dotty. I don't know. We'll try to make it work. It's kind of weird. Having some issues lately, so. And they still haven't fixed the problem with importing JPEGs and GIFs. So once again I had to take pictures of the homework. So I apologize for that because it's just the lower quality than I'm used to. So, but that's just what we'll have to work with. So that's all we can do. So let's take a look at these. So starting out, we've got to write the following in an exponent. Simplify when possible. Now remember, with roots make fractional exponents. So number 1, the fifth root of x would be x to the 1/5. Okay? The bottom number is the root. The top number is the power of the variable. So on number 2, we'd have s to the 2/7. And number 3, you'd have w to the 8/3. Now, that one can simplify, right? 8/3 is really like 2 2/3. So you have two whole terms, so that'd be like w squared times w to the 2/3. So you should try to split them up like that. But if you leave them at least like this, that's fine by me. This is really weird with all these dots. So now on 4 through 8, we're given numbers and variables. So we've got to think about, how we can reduce those variables. So you can kind of treat it separately, the number separately from the variable. Alright, well, I totally forgot where I was going because it's been about a half an hour and somebody came in and I had to deal with them. So I think we were on number 4. And I said you could split up the number with the variable, right? So you can treat them separately. So for the r, it would be r to the 6 over 3, which 6 divided by 3 is 2, so it's really r squared, right? Well, for 8, it would be 8 to the 1/3, but can't we rewrite 8 as something else? Yeah, it's 2 cubed. So if you thought of it like this, 1/3 times 3, well, it cancels out to 1. I'm really not liking the dots here. I can't write slow either. So it'd just be 2. So our answer would be 2r squared. Because the cube root of 8 is 2. That's kind of why it worked out. Alright. So, number 5, thinking about it the same way, 25, or 125. What is 125? Well, it's 5 times 25, and 25 is 5 times 5. So we've got 5 cubed. We've got m to the 5th. If you ever have the same root that you have the same power, that's going to be the same thing. It's going to be 1. It'll be 5 over 5, so it'll just be m. Okay? So we'd have the 5's, however, won't cancel out, so you'd have 5 to the 3/5 times m for number 5. So you should be trying these on your own, seeing how well you do. Okay? So number 6, and let me clear some space. Number 6. Now with this one, you've got the cube root of 8x squared. So it'd be like 8x to the 2/3. Now, remember, an exponential rule says that I can apply those separately. 8 we already decided was like 2 cubed. So it'd be 2 to the 3rd times 2/3 x to the 2/3. Because we just applied that 2/3, it's like we distributed it. Okay, those 3's cancel, so we're left with 2 squared, which is really 4. So it'd end up with 4x to the 2/3. Okay? So if we're looking at number 7, 9 is 3 squared. So to the cube root of that would be 3 to the 2/3. B would be b to the 8/3, but remember we can reduce that to be b squared times b to the 2/3. Okay? Now, number 8 is kind of different. Because 75, that's not a perfect square or anything like that. And we're in a square root. 75, however, is 3 times 25. And 25 is 5 times 5. So I can split it up, and you should remember when you did this, simplifying radicals, because I've got two 5s in a square root, we can get rid of one, bring the other, so it's really 5 square roots of 3 is what the square root of 75 would be, which I could rewrite that as 5 times 3 to the 1/2 times, now we've got 6 x's under a square root, so that would be x to the 6/2, which is x cubed. So our answer would be this. Alright, well there's all of those ones. Now, 9, 10, 11, and 12 are just rewriting with a fractional exponent. So we're just rewriting. Remember the rule is log base of the number equals x, and that becomes an exponent in the base of x to the x power equals n. So, if we're thinking about this one, first we'd rewrite this, and we'd go log base 3 of 3 to the 1/5 equals, now remember that rule we did, the base and that number when they're the same, okay, our answer is just 1/5, because if I rewrite this, it would be, the exponent would be 3 to the whatever power is equal to 3 to the 1/5, so our answer is 1/5. So all you have to do is rewrite them and then see that if there's that connection. So log base 2 of cube root of 4. So log base 2 of 4 to the 1/3. Now, those aren't the same number, but 4 is really 2 squared, right? So 4 to the 1/3 would be the same as 2 squared, oh, that's a 3, to the 1/3, or 2 times 1/3 is 2/3. Okay, 2 to the 2/3. So it's really log base 2 of 2 to the 2/3, so our answer is 2/3. Okay, so that's number 10. So let's clear some room now. Take a look at number 11. So 343. Notice our base is 7, so chances are it's 7 to the some power or something like that. Okay, 7 times 7 is 49. Times that by 7 again, and you get 3, 6, 28, and 34. So it's 7 cubed. So we really have log base 7 of 7 cubed, but it would be 3/5. So our answer, you kind of can eliminate those, 3/5. Number 12, we have 3, 1, 2, 5. Okay, notice what our base is. So 5 times 5 is 25. Times it by 5 is 125. Times that by 5. So we've got 1, 2, 3, 4. That would be 5, 2, 10, 12. 5 plus 1 is 6. Times it by 5 again. 5, 2, 12, 31. So it's 1, 2, 3, 4, 5. So it's 5 to the 5th power is what that is. And we're taking the 5th root of it. So that'd be 5 to the 5/5, or just 1. So we've got log base 5 of 5 to the 1 equals Okay? Now let's take a look at the next stuff. So 13 through 16 basically just wants us to expand and using those rules that we got from the math task. Okay? So remember, multiplication is just addition, so you rewrite it log base 5 of 7 plus log base 5 of x. Same with 14. Log base 5 of 10 plus log base 5 of 8. You just split those up. Now with 15, okay, we would go, it's division, so we do subtraction. So it would be log base 5 of 5 minus log base 5 of b. And 16 be log base 5 of d minus log base 5 of 4. And that's all there is to it. And so 17 through 24, it's that same process. Okay, same process. Now remember the exponential rule for like 17. That exponent can come down and it's 3 times the log base 6 of x. So on this one it would be 2 times the log base 5 of 9 plus log base 5 of x. Okay. Actually, I did that one backwards, didn't I? Yeah. Hold the phone here. This one would actually be, we should split it up first because that square is just with the x, not the 9. So it would be log base 5 of 9 plus log base 5 x squared, and then that 2 would just come down in that one. Phew, almost taught you guys wrong. So this is what it should be. 2 log base 5 of x. Okay. Now, the difference with 19 is like the one I did. That 4 would come down first, and then you would split it up. 20, think of it as log base 3 of w to the 1/2. So that 1/2 just comes down in front. Now 21, notice we've got the top here that are added, minusing the bottom one. So it would be log base 5 of x plus log base 5 of y plus log base 5 of z minus log base 5 of w. Okay, and you can keep working those out the same exact way. Okay, I'll do 24 for you for the last one. I'll let you guys try 22 and 23. Can't give you all the answers on this, right? So it'd be log base 2 of x squared minus log, if I put this in parentheses, base 2 of y to the 5th plus log base 2 of w cubed. Oh my goodness, you probably can't even read that, can you? So then all these exponents can come down. Okay, so it would be log base 2 of x, and that 2 would make it 2 times, minus 5 times log base 2 of y minus 3 times log base 2 of w. Just like that. Okay, now the last problems. You're just converting back and forth. So remember, the exponent is the base, so b to the x equals our number. And we swap that to the log base b of n equals x. So it would be log base 2 of 512 equals 9. Log base 10 of 0.01 equals negative 2. 27. Now these ones are different. You could write it log. Now, can we have a fractional? Well, that works, right? So log of 2/3 base of 3/2 would equal negative 1. And the other ones you just write backwards. So it would be the power of 4 to the 1/2 equals 2, right? Because that's like the square root of 4 equals 2, which is true. This would be the base 1/3 raised to the negative 1 is equal to 3. And 30 would be 2/5 raised to the third is equal to 8 1/25. So there you guys go. That's pretty much everything. Okay? And since you guys stuck around, let's take a look at 22 and 23. So 22, okay, that's like 9 times x to the 1/2, right, square root of x, y to the third. So it'd be log base 5 of 9 plus 1/2 log base 5 of x, because that 1/2 came down in front of the log, minus log base 5 of y. Now that 3 would go in front, right, because it's y cubed, so that 3 would come down in front. And the last one, 23. So now, that's x squared minus 4. You've got to treat that as one thing. We can't split that up. So it's log base 2, parentheses, x squared minus 4, because it's not multiplication, so we can't deal with it, minus log base 2 of x cubed. Now this x squared can't come down because you've got that whole minus 4, so you just rewrite this one. Log base 2 of x squared minus 4 minus 3, because the 3 comes down, times log base 2 of x. And there you guys go. Enjoy.